Hey guys, so in this video we're going to talk about factorials. Now what exactly is a factorial? Well, one way to understand this is by starting with an example. So here we have three people. We've got person A, person B, and person C. And I want to arrange these three individuals in a row from left to right. Now in the first position, in the leftmost position, I can start with person A. I can start with person A here. And person A can either be paired with person B or person C in the middle position. So person A can be paired with either person B or person C in the middle position. And then we're left with if B comes in the middle, then C is obviously at the end. And if C comes in the middle, then B is at the end. Now of course we can also start with B in the leftmost position. And now B can be paired with either A or C in the middle position. So if we start with B, then we can either have A or we can have C in the middle position. Now if we have A in the middle, then obviously we're left with C at the end. And if we have C in the middle, then we're just left with A at the end. And now the last possibility is that if we start with person C in the leftmost position. Now if we start with person C in the leftmost position, person C can either be paired with person A or person B in the middle. So we have person A or we have B in the middle. And then if A is in the middle, then we're left with B at the end. And if B is in the middle, we're left with A at the end. So over here, there's a total of 6 different ways. In which I can arrange these individuals, in a row from left to right. Now, another way to see this is that for the first position, for the leftmost position, here I had 3 different options. I could start with person A, person B, or person C. So I had 3 different options here. For the second position, once I've chosen the first person in this position, now I have 2 options left for the second position. So I could have started with A, B, or C. That's 3 different options. Once I have picked A, B, or C for the first position, now that person can only be paired with 2 other people. So if I've chosen A, for example, now I have only B or C left for the second position. If I've chosen person B, I have A or C. If I've chosen person C, I have A or B. So I have 2 different options for the second or the middle position. And now I'm only left with 1 option for the final position. So over here, the total number of ways in which these 3 people can be arranged is simply 3 times 2 times 1, which is equal to 6. And we can clearly see that we have 6 different ways in which we can arrange these 3 individuals in a row. And this 3 times 2 times 1 can be rewritten as 3 factorial. So here, this exclamation mark represents a factorial. And what this means is we're simply going to take the product of all the integers less than or equal to 3. So 3 factorial means we're going to take the product of all the integers from 3 down to 1. So 3 times 2 times 1. So there are 6 different ways of arranging 3 different individuals, or there are 3 factorial ways in which we can arrange 3 different things over here. Now let's say that instead of 3 different people, I have 5 different people I want to arrange. And I want to arrange these people in a row, again from left to right. Now if we start again at the leftmost position, there are 5 different people I can pick for this first position over here. There are 5 different people I can pick for this first position. Now it doesn't matter who we choose. We can pick A, B, C, D, or E for this first position. I can pair that person up with 4 different people. So for example, if I chose A, I can pair him up with either of B, C, D, or E in the second position. That goes for anyone. Whoever I chose in the first position, there are 4 different people I can now pair that person up with for the second position. For the third position, I have 3 different choices left now that I've already picked 2 out of 5. For the fourth position, I only have 2 options. And for the fifth position, I only have 1 option. So over here, the total number of different arrangements that I have is 5 times 4 times 3 times 2 times 1, which is equal to 120. And this product here, 5 times 4 times 3 times 2 times 1, can be rewritten as 5 factorial. So again, 5 factorial represents the product of all the positive integers less than or equal to 5. Or we can say it represents a product of all the integers from 5 down to 1. So we have 5 factorial ways of arranging 5 different objects. So these 5 different people can be arranged in 120 different ways, which is 5 factorial. Now again, if you were to state this more generally, if we had n different objects, if we had something like n factorial here, this is simply n times n minus 1 times n minus 2 all the way down to 1. So here n factorial is the product of all the positive integers less than or equal to n, where n is a positive integer. So again, by positive integers, we mean all the integers from 1 up to n. All the positive integers less than or equal to n are all the integers from 1 up to n. And n factorial represents the number of ways in which n different objects can be arranged. It's important over here to note that there have to be n different objects. So in the example that we saw, we had 5 different people here, or 5 different objects. The total number of arrangements for these 5 different people is simply 5 factorial, where this factorial represents the product of all the positive integers less than or equal to 5, where 5 is obviously a positive integer. So here what we see is that if we have one or more objects, the total number of ways in which we can arrange those different objects is equal to n factorial, where n represents the total number of different objects. But the question arises that what if we have 0 objects? What is 0 factorial? Well, one way to look at it is by looking at the following picture here. What we have here is, over here, I have the number of objects n. So if I have 5 different objects, the total number of ways of arranging them is equal to 5 factorial, which is equal to 120. If I have 4 different objects, the total number of arrangements is 4 factorial, which is simply 5 factorial divided by 5. If we take 5 into 4 into 3 into 2 into 1 and we divide that by 5, we get 4 factorial, which is equal to 24. The number of ways in which you can arrange 3 different objects is 3 factorial, which is 4 factorial divided by 4. And that's simply 6 different arrangements. The number of ways we can arrange 2 different objects is 2 factorial. That's simply 3 factorial divided by 3. So that's 2 different ways of arranging 2 different objects, right? We can have A, B, or B, A. And the number of ways in which we can arrange one object is just 1. There's only one way to arrange one object, and that's 1 factorial, which is 2 factorial divided by 2, and that's equal to 1. Now, if we follow this pattern, we see 4 factorial is 5 factorial divided by 5, 3 factorial is 4 factorial divided by 4, and so on. Well, we can say that 0 factorial over here is 1 factorial divided by 1, which is equal to 1. Now, I might say, why is 0 factorial not equal to 0? Well, by looking at this pattern, we can say that 0 factorial is equal to 1. But why do we have to follow this pattern? Well, we don't necessarily have to follow this pattern. The other way to think about this is that if you look at, for example, 3 different objects, we saw this earlier, and we know that there are a total of 6 different ways of arranging 3 different objects. We look at 2 different objects, there are 2 different ways of arranging these 2 objects. We can have A, B, or B, A. If you have just one object, there's only one arrangement possible. Now, what if I had 0 objects? How many ways can I arrange 0 objects? Well, over here, if I have 0 objects, that means I have nothing. And there's only one way in which we can arrange nothing, and that is nothing itself. So there's only one way in which 0 objects, or there's only one way in which nothing can exist, and that's nothing itself. So that over here answers the question as to why 0 factorial is equal to 1.